Inside of our loop, all we need to do is add each number to our result. So that could be an expression like result plus equals number, and that will allow us to compute the proper result. Let me run this without the debugger. Control F5 will do that. And I can see the result is 33.21. And what we've been doing is taking these little steps, and what we're working towards is the ability to store grades in a grade book and then compute the average grade. So now we can see how to loop through a collection, how to add up numbers, and I'm sure you'll be able to figure out how to divide one number by another number. But there's one big limitation of the code that we've written. The requirements don't tell us how many grades that we'll need to store. Will there be 1 grade, 10 grades, 1,000 grades, or 0 grades? We don't know. And when we're working with arrays in the C# language, we need to create arrays with a specific size. So I need to create an array with these 4 numbers, or I need to initialize an array that can store 10 floating point numbers. And that's not going to work well if we don't know how many grades the user might give us. Fortunately, the .NET libraries provide an answer in a namespace system.collections.generic. That namespace contains a number of classes that we can use that are data structures. Data structures like a stack and a queue, if you've heard of them. And there's also a simple data structure named a list. A list allows me to keep a list of things around, like a list of floating point numbers. And the way I would use a list variable would look like this. Let me use some explicit typing to say that I want a list of floating point numbers. Let's name the variable grades. And before I can use this list type, there's 2 things I need to do. First of all, when you see this error message that the type or namespace list could not be found, are you missing a using directive or an assembly reference? That is the C# compiler telling you that I don't know what this is. I don't see this type, this class, or this thing that you're trying to use anywhere. And sometimes this is simply because the type that you want to use is in a namespace that the C# compiler is not looking into. So every class in the .NET framework is going to be in a namespace of some sort. Namespaces help to reduce the collision so that if I write a class called list and you write a class called list and the .NET framework has a class called list, there's still an easy way to differentiate the 3 because the 3 will essentially have different names as long as they're in different namespaces. An example would be this console class. We saw earlier when I used a code snippet that this class is actually named system.console. System is the namespace that the console type lives inside of. But I don't have to explicitly say system. I can do this. This is legal C# code. But I can remove the system namespace as long as I have a using statement to let the C# compiler know that it should be looking in the system namespace for any types that I use. So now I can use anything inside of system, and there's quite a few types inside of the system namespace, but list is not one of those types that is in the system namespace. Now sometimes it's very easy to find the namespace and the tools are going to help you. So if I place my cursor directly on that list where there's a red squiggly and I press Control and period, this is bringing up a menu that will help me try to fix this particular error. So the first fix in this list of fixes is to add a using statement to this file for system.collections.generic. I want to highlight that entry and I want to press enter. And that is at the top of the file going to add using a system.collections.generic because that is where the list type lives. It is technically system.collections.generic.list. But I still have an error on this line of code because this type requires 1 type argument. What is a type argument? Well, there's certain classes and types in the .NET libraries that require you to provide some additional information about how you're going to use that particular type. So for example, when I want to use a list, in order to use that list, I have to describe what types of things I'm going to put into that list. Are they going to be invoice objects or employee objects or integers or date times or strings or double precision floating point numbers? In this case, what I want is a list that will only store double precision floating point numbers. And the way I describe that is to use an angle bracket and to put the type double here. So what I'm saying is that I have a variable named grades, and grades will be typed as a list of double. So just like the previous variable is an array of double, this is a list of double. It's just the syntax is a little bit different. And yes, I can also use the var keyword here if I have the right kind of initialization statement. So again, grades, before I can use grades, I need to initialize grades. And once again, I will need to use the new keyword to say, I want this variable to point to or refer to a new list of double. Now, yes, the initialization syntax for an array is a little bit different than the way we initialize most of the other types that we use on a day-to-day basis. And what we're seeing here with the new list and the parentheses, this is a syntax and a format you'll become accustomed to because this is how we use most of the types inside of .NET. The parentheses almost imply that I'm invoking a method here to create this list of floating point numbers, and in fact, as we're going to see in the next module, that really is what is happening. There's a special method that can create my list of double. And at this point, I can use grades very much like an array with the addition of being able to add things into it. So unlike an array, which has a fixed size and it can be difficult to add new things into an array, it's possible, but it's just not very efficient. A list is implemented from the start as this dynamically sizable collection that you can just keep adding and removing things from. So notice when I want to add something to a list, I have to add something that is of type double, which makes sense. So I can say, let's add the value 56.1. And then just like an array, I can also index into a list. So I can say, let's look at the first element in that list. What is it? It's grade sub 0, just like I would go to an array sub 0 to look at the first element. So arrays and lists share a lot of the same behaviors and features. It's just that a list is dynamic. I can add new things into it. So up here, let's change this to use implicit typing. I'm just going to say var grades equals a new list of double. And in fact, just like with an array, I can provide an initializer if I just want to go ahead and add some values into that list right from the start. So now my list contains the same 4 numbers as this array. It's just that with this line of code, I'm adding an additional number. So in addition to sharing some of the same initialization format and being able to index into a list, I can also use a for each statement to iterate or loop over that list. So instead of saying for each number in numbers, I want to say for each number in grades. And if I run this program with Control F5, I will see the result, 89.31, which looks about correct. And now what I'd like to see you do is compute an average for all the grades that are now stored in the grades list. Now when you do that, I don't want you to just take the result and divide it by 5 and hard code the value 5. What I want you to do is figure out how to find the number of items that are in this list. Just like an array has a length property, a list has a property that will tell you how many things are stored in the list. It's just that that property is not called length. But see if you can use the tools or the documentation or the IntelliSense that pops up after you press a period to figure out what you can use to compute the average.